Okay, we're going to go ahead and look at how to write some polynomial equations. The main thing we're going to focus on is the ones with linear factors. These are just easier to handle with. If the factors are pretty rational numbers, it's going to be linear factors. And remember, we can use the degree to check our answer. Let's go ahead and get into a few examples. This first graph, let's say it has x-intercepts of -4, 0, and 1. Well, to write this in factored form, with -4, 0, and 1, just take each x-intercept and write it as a factor. So the first one there is going to be an x plus 4. We've done this before. The next one will be an x minus 1 for the positive 1. And now let's talk about the 0. Technically, I could do an x minus 0, or for that matter, x plus 0. But x plus 0, x minus 0 doesn't make any difference. So we're just going to use a plain x. So that 0 is a factor of a plain x. We're going to put it out in front, and that's going to be what we have. Now, the next thing I'm going to need to do is I'm going to need to check and see if any of those x-intercepts have a multiplicity. This one just looks like a straight line, so that doesn't have a multiplicity, or it would just be a multiplicity 1. That goes straight through. But notice right here in the middle, I'm going to do this in pink so it stands out, is that kind of looks like an x squared right where it touches there. So what we've mentioned is if that looks like an x squared, that needs to have a multiplicity of 2. The factor that gave you that one was the 0. So that means it's going to be an x squared times x plus 4, x minus 1. Now using the degree to check, I have a total of 4 x's, and here's why I say that. I have 2 x's here, plus 1 x from this factor, and 1 x from this factor. That's a total of 4 x's. So since I have 4 x's, that means I'm looking at a degree of 4 for this polynomial. And if I look at my graph changes directions 1, 2, 3, 4 times. It goes up, that's 1 direction, down, that's 2 directions, back up a little bit, that's 3, back down again, it's 4. The final thing I need to check is my end behavior. Since it's an even degree, the ends should match, which is good, but notice it goes down on the right-hand side. Well, what that means is since it's going down on the right-hand side, it needs to have a negative leading coefficient, so that is going to be my final answer for that one. We'll go ahead and work through a couple more examples in just a second.